So we completed with the third unit, CRO. Today we will discuss about the fourth unit, that is transducers. So if you see transducers, so what is a transducer? So it's a measuring device. Mainly it consists of input and a signal conditioning or processing device and output device. So input device means it will receive the measurement, whatever the quantity the transducer want to measure. So it will take the measure, and signal conditioning means it is given to the signal conditioning circuit. That means in signal conditioning, it can do either filter or amplify or attenuate or modulate. So whatever the processing takes place, that will be held in signal conditioning circuit, and you have the output. So whatever the measured value is there, you will get in the output. So whatever the measured value. So if you want to see measured value either in displays or it may be in the readings, so that will be displayed on the output. That is, result is getting on the output device. So that means so which quantity we need to measure. So mainly in the measuring devices, we need to measure a non-electrical quantity. So now whatever the non-electrical quantity like temperature, pressure, humidity. So whatever the non-electrical quantities are there, that will be given to the measuring device. So this transducer will convert this non-electrical quantity to electrical quantity. So here, if you see the definition of transducer, transducer is a device which converts non-electrical quantity into electrical quantity. So that means here, if you see, uh, here non-electrical quantity is a energy element. So electrical non-electrical quantity can be an energy thing, and here electrical quantity is energy. So that means here what the transducer is doing, transducer is converts one form of energy to another form. That means either a non-electrical quantity is one type of energy and electrical quantity is one type of energy. So basically the transducer will convert one form of energy to another form. That means it will convert one form of energy. So one form of energy to another form. Okay. So let us consider two examples of transducer. So consider mercury thermometer. Mercury thermometer. So input for the mercury thermometer, it's a type of transducer. So input for the mercury thermometer is a temperature. Okay. Inside there will be a mercury. So depending on the temperature, here some readings will be there. Like a temperature 0 degrees, 25 degrees, and 50 degrees, 100 degrees Celsius. Temperatures will be there. Depending on the temperature, this mercury level, that means mercury level will increase or decrease. That means what happening, the temperature, whatever the temperature is, the temperature is converting into the length of the mercury. Length of the mercury. So through the indication of this mercury, we can find out the how much temperature the body presents. Like that, a mercury thermometer will work. And another example is a manometer. Manometer, what it will do, the input for the manometer is a pressure. So whatever the pressure is coming, that is a non-electrical quantity that is given to the manometer. So manometer will convert the pressure. So pressure we can't measure directly. So it is given to the manometer. Manometer will convert the pressure into a meter, so that we can find heat intensity, intensity of light, flow rate, liquid level, humidity, pH value. These are all are non-electrical quantities. So, transducer. So what the transducer will do? Transducer provide an output signal when stimulated by mechanical or non-mechanical input. That means the input of the transducer may not be a mechanical quantity. It can be a non-mechanical quantity also. Non-mechanical quantity means like pressure or temperature like that. So it will stimulate. That means it will convert either mechanical or non-mechanical quantity to a measurable value. So what the transducer basically consists of? It consists of two elements. One is sensing element, another one is a transduction element. So what is a sensing element and what is transduction element? So that means here, for the sensing element is nothing but we can call as a sensors. For the sensing elements, you are giving a non-electrical quantity to the sensing element. So what the sensing element will do? This is a physical quantity or it is rate of change. It is sensed or responded. So what is the means amount of rate of change of this whatever the sensing element is there, that is given to the sensor. So output of the sensor is given to the transduction element. So what that so basically transduction element is a transducer. So it will convert a non-electrical quantity into a proportional electrical quantity. So if you get a proportional electrical quantity, so you'll get an electrical signal. We can measure that electrical signal by using like any measurable meter like voltmeter or ammeter like that. Okay. So these are the two basic components present in the transducer. Okay. So coming to one example, that is a thermocouple. So what the thermocouple will do? It generates a voltage corresponding to heat that is generated at the junction. So that means here there are two dissimilar metals will be there. So one metal is having different temperature, another metal is having another different temperature. So consider it is having 0 degrees Celsius, it is having some finite temperature, T degrees Celsius. So what happens? Here heat is there. So whatever the heat generated between these two dissimilar metals is converted into voltage. So if it is converted into voltage, means we can measure the voltage. So this is how a thermocouple will operate. So some of the examples of transducers are microphone. Microphone, what the microphone will do, whatever the sound signals are there, that will be converted into electrical impulses. And suppose light bulb means here the transducer not only convert electrical, mechanical energy, mechanical or non-mechanical to electrical form, it can also convert electrical form to some mechanical form. So if you see the electrical bulb, here the input for the electrical bulb is electrical energy. So you are getting light bulb is getting the electrical energy. Electrical energy is converted into optical energy. So whatever the optical, it will give the light. Okay. So that means there also electrical is one type of energy and optical light is one form of energy. What is it? It is doing, it is converting one form of energy to another form. Similarly, electric motor is there. Electric motor, what it will do, it will convert the electricity to mechanical energy. So whatever the mechanical, that means it will rotate. So that means you are giving the electricity, it will converting into mechanical energy. These are the some examples of the transducers. So means you got one idea what is a transducer. So same thing. So a transducer is a device which is convert one form of energy to another form. So it converts measurand to usable electrical signal. So whatever the measurand is there, so it will convert into usable electrical signal. So here, in other words, we can say that it is converting a physical quantity to proportional electrical quantity. Physical quantity means either it may be a mechanical form or non-mechanical form. So that is a physical quantity into electrical form. Electrical form means it such as a voltage or current. So example, pressure or voltage. So as I told you, block diagram of transducer, it consists of two elements, sensing element and transduction elements. So sensing elements are basically sensors. So, what the sensors will do, it will produce a measurable response to change in physical conditions. So that means whatever the change in physical conditions are there, that will it will bring it to change in physical quantities. Okay. So these are the characteristics of transducers. So ruggedness, linearity, repeatability, accuracy, high stability, speed of response, sensitivity, small size. It should be small size. It should sensitive to the input. So these are the not that much important. So coming to the classification, so classifications are there in our syllabus. Uh, so transducers can be classified into 5 types. One is active or passive transducers, analog or digital transducers, on basis of transaction principle, primary and secondary transducers, and transducers or inverse transducers. So if you see active transducers, so as you know, active elements are nothing but those are giving the source. That means like a voltage source, current source, those are nothing but the active elements. No, here also for the active transducer, there is no need of a external power source. Power source is required for the active transducers. Okay, so that means as those are self-generating type transducers. That means that whatever the power required for the transducers, it will generate by themselves. That's why we call as the active transducers. So we can call this active transducers as a self-generating devices. So which are operating under energy conservation principle. So examples of active transducers are temperature or strain to electric potential. These are the active transducers. See here, piezoelectric transducers. So here, what happened? What so if you applying a stress or force to the piezoelectric device, so due to crystals present in the piezoelectric device, so the due to motion of the piezoelectric device, that motion is converted into a electrical signal. So the electrical signal is displayed on the voltmeter. So this is one type of active transducer. So no need of external power supply is required for the piezoelectric transducer. Coming to the active transducers, those are classified as photovoltaic, thermoelectric, electromagnetic, piezoelectric, chemical, and other. These comes under the active transducers. So passive transducer means the passive transducers. It's like a passive elements like resistor, capacitor, and inductor. So for those elements, you need an external power supply. No. So here also for the passive transducer, you need an external source. You need an external source of power for their operation. Okay. So they are not self-generating. Okay. You need a external source. So DC supply or audio frequency generator is used as external. So yeah, you should give a DC power supply or audio frequency generators. So whatever the audio frequency generators, you need to give as external power supply. Power supply for the passive transducers. So these transducers will produce the output signal in form of variations in. So that means they can produce output in variations in either in resistance, capacitance, or inductance. So either in it will give an output in terms of resistance or capacitance or inductance. So here, if you see, so passive transducers, there are different types classification of passive transducers. Variable resistance. So that means you are here variable resistance means the output is giving. It is giving the output in terms of resistance. These are the examples of variable resistance. Strain gauge. In strain gauge, we'll see in this in the preceding PPTs. Thermistor, potentiometer, photoconductor is a LDR. So these are a variable resistance. Variable reactance are inductive and capacitive. In the inductive, you have variable reluctance, variable permeability, and LVDT. And optoelectronic, photoemission, and photoconductive, and Hall effect. So these comes under the passive transducers. Okay. So next, primary and secondary transducers. So that means in some cases, one is acting as primary transducer. So you are giving a physical quantity to primary transducers. So the output of the primary transducer is given to the secondary transducer. So the output of the primary transducer is given to the secondary transducer. So here example, so some transducer contains mechanical as well as electrical devices. So mechanical device is converted into physical quantity to be measured. So whatever the mechanical device, what it will do, it is acting as a primary transducer. It converts whatever the physical quantity is there uh, into a mechanical measurable, so measurable mechanical signal. So that mechanical device is acting as a primary transducer. So whatever the mechanical device is there, that is acting as a primary transducer. Again, the measurable value is given to another transducer. So that secondary transducer. So what the secondary transducer will do, whatever the measurable mechanical signal is there, that is it converts mechanical signal to corresponding electrical signal. Okay. So in that situation, it is acting as a secondary transducer. So example here, if you see strain gauge. So if you consider the strain gauge, so this is a strain gauge. So here there is a diaphragm. Diaphragm is there. So what the diaphragm is there? Here diaphragm is acting as a primary transducer. So what the diaphragm will do? It will convert. Here you are applying a pressure. You are applying a pressure. So whatever the pressure is there, so that is a physical quantity. It is converting into mechanical quantity. That is nothing but a displacement. So it is converting a pressure into displacement. See here, pressure into displacement. Again, it is given to the strain gauge. What the strain gauge will do, depending on the stress, depending on the stress or the compression, so it will convert that whatever the displacement into voltage. Okay, so that means here diaphragm is acting as a primary transducer, which is converting it converts pressure to displacement, and strain gauge is acting as a secondary transducer, which is which converts a displacement into voltage. Okay, this is one form of the primary and secondary transducers. And next, classification of transducer based on the transduction principle. So transduction principle means, so here there are some examples: capacitive transduction. Capacitive transduction means depending on the capacitance between the two plates. Okay, so that is depending on the transduction principle. Electromagnetic transduction, inductive transduction, piezoelectric transduction, photovoltaic transduction. These are some transduction principles. So if you see capacitive transducers, so capacitive transducers measurand is converted into change in capacity. So depending on their property, so depending on their capacitive property or inductive property, so that we call as a transduction principle. So here, depending on the capacitance property, it will measure whatever the physical quantity into whatever the measurand is there, that will be converted into capacitance. So that means, as you know, the capacitor is a two parallel plate capacitors. So whereas insulating material is called dielectric, we will keep between the capacitance. What is the purpose of dielectric? It is help to two parallel plates maintain stored electrical charges. So as you know, the capacitance is given by epsilon naught, epsilon or A by D. So where epsilon naught is absolute permeability, epsilon r is relative permeability, and A is the effective overlap. Classification of so here, see here, based on the electromagnetic transaction means, here there will be a fixed coil, and this is nothing but a permanent magnet moving between this coil. So that means when you're moving this permanent magnet between this fixed primary coil. So what happens? There will be, due to electromagnetic effect, there a voltage will be induced. Okay, due to when you keep stationary, there will be no voltage. When you move this one, there is a voltage will be induced based on this is nothing but Faraday law of induction. See here. So when you keep these are the current induced in the coil. Examples of current. Suppose when you keep magnet at rest, there will be no current in the coil. When you move the coil, magnet is moving. Current is induced in the coil, and second current carrying coil moving relative to stationary coil. So here he kept a permanent magnet. Here he kept both are coils. Okay. So Second and current carrying coil at rest means there will be no induced in the current. Okay, so these are nothing but based on the induction principle. Piezoelectric effect means piezoelectric induction. The measurand is converted into. So as I told you, if you give a mechanical stress to this one, so if you give mechanical stress to this one, so whatever the crystals present in the piezoelectric transducer, so that will be converted into either charge or voltage. So electrostatic, it will be converted into electrostatic charge or voltage. This is photovoltaic. So in photovoltaic, what you are doing, your voltage is generated between two dissimilar dissimilar materials. Okay. So when the light is falling on these two dissimilar materials, a voltage is forming between this. This is the mechanism of photovoltaic generator. You have p-type semiconductor, n-type semiconductor, and there is a depletion layer, depletion zone, and so when these are the electrons, when the light is passing falling on these electrons will move from p-type to n-type. So that means it will pass from p-type to n-type, so that a voltage will be generated. Photoconductive means so measurand is converted into change in resistance. So whatever the change in resistance of the semiconductor. So the transducer and inverse transducer. That means so what the transducer will do? Transducer will convert non-electrical quantity to electrical quantity, whereas inverse transducer will convert electrical quantity to non-electrical quantity. So that means in the previous slides we have seen like bulb. So bulb, what it will do? It will convert electrical quantity to so that means electrical quantity to light energy. Whereas motor is there. Motor will convert electrical quantity to mechanical. So in that situation, we can call this bulb and motor as the inverse transducers. Resistance transducers means, so as we seen, passive transducers, you have resistive transducers. So resistive transducer means you are getting the output in terms of resistance. Okay, as you know, resistance R equal to rho L by A, where rho is the resistivity of a conductor and L is the length of the conductor and A is the cross section of a conductor. So that means if you give a stress compression or if you give stress to the material, the length may increase or diameter may decrease depending on the what stress or strain you are giving. Okay, so in this there are four types of resistive transducers are there: potentiometer, hot, strain gauge, thermistor, resistance thermometer. Okay, so mainly today we will see the strain gauge. This strain gauge, strain gauge is a passive or resistive transducer which converts mechanical elongation. So whatever the mechanical elongation is there or compression is there into resistance change. So the change in resistance is the output of the resistive strain gauge. So whatever the resistance change in resistance is there that take place in the variation of length and cross section area. Okay, so there are three types of strain gauge: are unbounded, bounded, foil type, and semiconductor gauge. So in our syllabus you have unbounded and bounded. So today we'll see the derivation for the strain gauge. One second. see this transducer. So strain gauge. So as you seen, can you able to see this one? Strain gauge. So it is a example of passive transducer which uses the variation in resistance to sense the strain produced by force on a wire. So whatever the strain we are producing on the wire, it gives the change variation in the resistance. It will convert strain produced on the wire or force on the wire. It will convert the force on the wire into variation of the resistance. That means strain is actually it is defined as elongation or compression per unit length. This is nothing but the strain. So metal stretched or compressed. So when you stress or compress the metal conductor, it will be converted into resistance change. So types of stress can be a positive stress or negative stress. So what is positive stress? So when gauge is subject to positive stress, so its length will increase. That means if you elongate, that means if you make positive stress, the length will increase. So as resistance is directly proportional to the length, so parallelly, if length is increases, resistance will increase. Negative stress means when gauge is subjected to negative stress. That means if you compress the wire, okay. So positive stress is nothing but you are elongating the wire. So length will decrease. So when length will decrease, resistance will also decrease. Okay. So this is how the types of stresses are there. And next, so see here. So as you've seen, a strain gauge, it's a passive resistance. So passive resistance means passive resistive transducer. So it will convert the mechanical displacement into. So as we've seen, it is given to the diaphragm. Diaphragm will convert the pressure to the displacement. It will convert the whatever the physical quantity. That means mechanical displacement to the resistance. So stress is defined. What is stress is defined? Stress is defined as a force experienced per unit area plus strain is nothing but change in length per unit length. So stress is nothing but force experienced per unit area as strain is nothing but change in length per unit length. Okay. So here principal operation means what is the principal operation? There will be change in the resistance due to increasing. That means tension or reducing. Means increase with the tension. That means if you increase the length of the wire or compress increase the length of the wire, so what happens? There will be change in the resistance. Change in the resistance. How we can measure the change in the resistance? The resistance, whatever the resistance to be measured, that will be given to the Wheatstone bridge. Okay, by Wheatstone bridge, we can measure the change in the resistance. Materials used are we will use alloys 45% nickel, 55% copper, nichrome alloy 80% nickel and 20% chromium. In this, one of the important thing is gauge factor. So for the strain gauge transducers, so one of the important thing is gauge factor. So if you see the gauge factor, so formula for the gauge factor is it is defined as unit change in the resistance or unit change in the length. This is the gauge factor, unit change in the resistance, unit change in the length. Where R is the gauge wire resistance, delta R is nothing but change in the resistance, and next L is the length of the gauge wire, and that delta is the change in the length on stressed conditions. Okay, so today we'll see the how we can derive for the strain gauge. See here. So see here. As you know, so this is the derivation for the strain gauge for the resistance, strain gauge of the resistance. So as you know, the resistance is defined as R equal to what? Rho L by A. So rho is the resistivity, L is the length of the wire, and A is the area of cross section. So we have to differentiate. That means the dr by respect to delta. So dr by d delta equal to what? D by d delta into rho L by A. So that means these three are variables. So that means you have to differentiate each and every variable. So if you are differentiating with rho, means you have to consider L and A as constant. So that means you are differentiating with respect to L. So that means these two, rho and L, A are constant. No? Rho by A. So partially you are differentiating. So partial differentiation. Rho L by dou delta minus 1 by A. So 1 by x is differentiating how much? Minus 1 by x square. No? So minus rho L by A square. Dou A by dou delta plus L by A with respect to rho means dou rho by dou delta. Now, so d delta get cancelled. You are getting dr. So dr equal to what? Rho by A dou L minus rho L by A square dou A plus L by A dou rho. Now what you should do? You have to divide both LHS and RHS by what? Uh, R is nothing but rho L by A. No, R equal to rho L by A. So dr by R equal to rho L by A dou L into rho L by A minus rho L by A square to dou A by rho L by A L by A dou rho by rho L by A. Okay. So here if what happens, rho get cancelled, L get cancelled. What you will get? Dr by R equal to rho L by L minus here A square cancel, rho cancel, L cancel. You are getting 2A by A, 2A by A, and next 2A by A, and next here you are getting 2 dou rho. Dou A by A, here you are getting dou A by A, here dou rho by rho. Dou rho by rho. But you know that A equal to what? Pi d square by 4, no? So A equal to pi r square. Pi r square, R equal to what? D by 2. So R square is equal to D square by D by 2 whole square. That means pi in terms of diameter, you can write area as pi d square by 4. Now you have to differentiate this area with respect to S. Okay. So dou A by dou S equal to pi by 4 2D dou D by dou S. Okay. So dou A dou S cancel. Dou rho equal to how much? Dou rho equal to pi by 4 2D into 2D. Now divide A by on both sides. So dou rho by A equal to pi by 4 2D rho D 2D rho D by A. So what is A? Pi d square by 4. So pi get cancelled, 4 get cancelled. So 1D get cancelled. What you are getting? 2 by D dou D. You are getting 2 by D dou D. Dou A by A equal to 2 by D dou D. So why you are doing this means in this equation you want this one. You want dou rho by A, no? So what is dou rho by A? Dou rho by A value you got as 2D by D into dou D. So O R by R, substitute this value in this above equation. So what you are getting? Dou rho by R, dr by R equal to 2L by L minus 2 by D into rho D, rho L by L minus 2 by D rho D plus rho, what you get here? Rho, dou rho by rho, Now what you should do? You should divide. So you got dr by R, no? What is gauge factor? Rate of change of the resistance to the rate of change of the length. Dr by R by dl by L, no? So divide this above equation by dl by L. Dr by R by dl by L equal to, so dou L by L will get cancelled. You are getting what? 1 minus 2 rho D by D by rho L by L plus dou rho by dou L by L. So this is the equation for the gauge factor. This is the equation for the gauge factor. So this is how you can find out by using for the strain gauge. You can find out the gauge factor.